All right, we're back to 9.4, looking at some mixed examples using law of sines and law of cosines. Now, in this example, we are given triangle DEF. D is 66 degrees. D to E is 4.88 feet, and E to F is 6 feet. We need to find the measure of angle E, this one here. So, to do so, because E would match with this side and we don't know that side, we can, instead of trying to find this side, we can try to find this angle F and then just use 180 minus this angle minus this angle. So we're going to use law of sines. Say that sine of 66 matches with 6 right here. Sine of F matches with 4.88. So F is this one here. Once I know this angle and this angle, I can figure out this one. So I don't have to use directly the law of sines to figure that one out. But when we're at this point, we just cross multiply, and we would get 4.88 times the sine of 66 equals 6 times the sine of F. Now, like we showed before, divide by 6 on both sides. That's how to get rid of that piece. Then you have to take the sine inverse of both sides. So all of this sine inverse, and we showed you how to do that on the calculator before. So this all together equals F. Show that out on your calculator, and you would get that F equals 48 degrees. So I'm just going to write that in here real quick. 48 degrees. We'll round to the nearest degree for this one. Now, how do I find my missing value angle E? Well, it's just 180 minus 66 minus 48, so it comes out to 66. So E here is also going to be 66, which means technically, if this angle is 66 and is across from a 6-foot side, and this angle is 66, it should also be across from a 6-foot side. So we accidentally solved the entire triangle just by figuring out this one angle. All right, example 2, solve triangle GIH. Now remember, to solve a triangle, it means you're solving for every single part of it. So right now, we just have 3 sides, 6 yards, 5 yards, and 4 yards, which means we're going to need to start by finding one angle at least, and then we'll work from there using our law of sines to find another angle, and then use 180 minus those 2 angles to find our last angle. So first we're going to look for angle G, just because I picked angle G. It really doesn't matter which one. But angle G is across from 4, so 4 has to be our C value. And then it doesn't matter what order you use. I'll use 5 as A and 6 as B. So 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of G. We're not sure how big it is yet, so we have to leave it as the cosine of G, equals 4 squared. Now, to get rid of all that, or to simplify it down, 5 squared is 25, 6 squared is 36, 2 times 5 times 6 is going to be 60, so it's 60 times the cosine of G. All of that equals 16, 4 squared. To get rid of these, we'd have to subtract 25 and subtract 36, which means we're subtracting all of those numbers over here. So we're left with negative 60 times the cosine of G equals negative 45. Getting rid of that on both sides, we divide by negative 60. There we go. Which means the cosine of G is going to be 0.75. To get G all alone, then we do the cosine inverse on both sides. So cosine inverse of 0.75, which means G is going to come up to about 41 degrees. We'll round it to the nearest degree and leave it as 41. Okay, now that we know that, we can use our law of sines. So 41 matches with 4, Sine of 41 over 4 equals, I'm going to use h this time. I'm looking for this angle, sine of h, so it matches with the side across from it, 5. So using law of sines, we cross multiply to solve it out. We would say that 5 times the sine of 41 equals 4 times the sine of h. Now working our way backwards, kind of balancing this, we divide by 4 on both sides. It's going to cancel that out. And we have to take the sine inverse of both sides. Sine inverse of all of this. That's going to cancel that out. So h is alone equals all of this, which means that h is going to come to 55 degrees. I'm going to write that in. 55 degrees. And to solve for our last piece, we just take 180 minus 41 minus 55, and we get 84 degrees. So this last one is 84. And now we've solved for the triangle. We know every single piece of it. All right, example 3, solve triangle TUS. From P to U to S, we've got 2 different sides that surround just one angle. So we're going to have to start by using our law of cosines, because we don't have anything that matches up. If we had like an angle here that matched up with this side, that would tell us we can use law of sines. But because we don't have any angle that matches with the side, we have to use law of cosines. So plug in the pieces that we know. I'm going to call 7.5 A, and 5 I'm going to call it B. So this is going to be my angle C right here. When I plug everything in, it's going to be 7.5 squared plus 5 squared minus 2 times 7.5 times 5 times the cosine of 85 equals C squared. I want to put a star right here. We're going to come back to this part at the end. Okay, but we're going to keep moving from here. Simplifying all of that out, 7.5 squared becomes 56.25. 5 squared is 25. 2 times 7.5 times 5 times the cosine of 85 comes to about 6.5366. I rounded it to the nearest 10,000th there. Now, simplifying all this, this plus this minus this gives us 74.7134. How do we get rid of that square root on both sides, or the square? We square root both sides. That's what I meant to say. Now this cancels out with this, so we just have C alone equals the square root of 74.7134. Plugging that in, we get that it should be about 8.6. So 8.6 should be our C value. Now coming back to this piece here, notice how there are no more variables here. Instead of simplifying this all piece by piece, we could, at this point, put in our square root on both sides. The square root goes over the whole side, which means C alone equals this whole piece. If you are very careful, you can plug this into the calculator all at once. It looks something like this. Start with your square root. So the square root of 7.5 squared. Oops, missed the 7 on that. 7.5 squared plus 5 squared minus 2, and I'm just going to put it in parentheses, times 7.5. Missed the 7 again. The calculator is smart enough to realize that those parentheses there means that each of these pieces are being multiplied. So this is our way of telling it, multiply these things. So 2 times 7.5 times 5 times the cosine of, I just want to double check, it was 85. So what we have here, all of this together, is exactly what our thing said. Now in the end, when we solved it out, we got it should be 8.6. According to the calculator, if we solve that out, 8.64368 and so on. So again, it would still round to 8.6. Now if your calculator doesn't give this extra long square root bar at the top, just put an extra set of parentheses in front of this 7.5 and at the very end to say all of this stuff is underneath the square root, and your calculator will solve it all out for you in one big step. So in the end, 8.6 feet, technically, 8.6 feet is going to be this missing leg over here, this missing side. Now that we know our missing side, we can go back and just use our law of sines. 85 matches with this one. So we would use sine of 85 over 8.6. Sine of I, actually, sorry, that would be t. Get rid of that, call it a t. Matches with 5. So cross multiplying, I think I wrote I down here. Oops, not y, t. So 5 times the sine of 85 equals 8.6 times the sine of t. Getting all of that alone, we divide by 8.6 on both sides. Those will cancel out. And we have to take the sine inverse on both sides. That cancels out, that cancels out. So it's the sine inverse of all of this equals t. Plugging that into the calculator, we would get t equals 35 degrees. Now that we know t is 35 degrees, we have 2 degrees or 2 angles in this triangle. So to find that last one, it's just 180 minus 85 minus 35 equals 60. So this then is a 60-degree angle. And we've solved out the entire triangle. Example 4, triangle ABC has angle A being 32 degrees, angle B being 81.8 degrees, and side A being 42.9 inches. What's the measure of side C? Well, step 1 in any problem like this is draw that picture. Whatever they told you that you would have, draw that whole thing out. So we will have ABC as our triangle. Angle A, they told us, was going to be 32 degrees. Angle B is going to be 81.8 degrees. And this side A is going to be 42.9 inches. Better put on my unit there. So, now that we know 2 angles, we can find this third pretty easily. 180 minus each of those. So we'd get 66.2 degrees is our angle C. So now we know all 3 angles, we know one of the sides, and we're looking for this third side, or one of them, C, over here. Well, we can just use our law of sines to figure that out. Sine of 32 matches with 42.9, sine of 66.2 matches with C. Cross multiply and we would get 49 or 42.9 times sine of 66.2 equals C times the sine of 32. To get C alone, we divide both sides by the sine of 32. All of this over the sine of 32. Those will cross out. We just have C alone. Punching that into the calculator then gives us that C is going to be 74.1 inches. And that would be our final answer. Example 5 then. An observer is near a river and wants to calculate the distance across the river. He measures the angle between his observations of 2 points on the shore, one on his side and one on the other side. Now that angle is going to be 28 degrees. So he's standing here. There's 2 points on the river, one here, maybe 2 trees or 2 big signs. He measures that angle between those two as he looks straight at them to be 28 degrees. The distance between him and the point on his side of the river, so this over here, he can just walk right over, and he measured it out to be 300 feet. The angle formed by him, the point on his side of the river and the point directly opposite, is 128 degrees. So he can measure this angle on his side of the river. He can't walk over here, so we can't measure it because there's a big river right here. But if this is 28 degrees and this is 128 degrees, he can figure out this has to be 24 degrees. He walked 300 feet here, so he wants to know how far across the river it is. Well, now that we have all three angles and one of our sides, we can just use the law of sines to find out the distance across the river. So the sine of 24 matches up with 300, 24 and 300 right here, equals the sine of 28, which matches up with r. Cross multiplying will give us 300 times the sine of 28 equals r times the sine of 24. Getting r alone, we just divide by the sine of 24. Divide by sine 24. These are going to cancel out, so we have r alone, which means r is going to come to about 346.3 feet. So without having to go all the way across the river with a big tape measure, by the way, tape measures do not go 346.3 feet long, so it might be impossible to measure that. He can use trigonometry to find out the distance across the river is going to be 346.3 feet. And that will be our final answer for our final example.